All right. So let's begin. In the previous class, I told you that I'd be teaching you a little bit of trigonometry, isn't it? So just enough trigonometry to deal with vectors. Okay. So this will not be a proper trigonometry course for you. So just enough. And I'll give you some guiding problems so that you can get the hang of this trigonometry. All right. So trigonometry, what does it mean? Trigonometry. Metry. What is metry? Meter. Metry. Yes, Neha, what does metry mean? What's the meaning of that? What does it mean to you? At least meter or metry, geometry, trigonometry?
Measurement.
Okay. Was that a guesswork?
Yeah.
Very good. Metry means measurements. Okay. So trigonometry, trigon. What does that mean? Trigonometry. Neha, since you are very good at guessing, yeah, tell me, what is trigonometry?
The measurement of triangles.
Yes, done. Okay, see, guessing is not bad, right? Trigonometry. Tricon means, what does tricon mean literally? I'm wondering. Three means three, of course. Cone means what? Tricona. Cona.
Corners, sir.
Corners. Okay. Three corners.
Corner.
All right. Cones actually mean angles, okay, in Kannada. Konagalu. Not kona. Kona would be a different thing. Okay. What is a kona, Sandra?
I don't know.
Kona is ox. Okay. Kona means angle. Okay. Three kona. So we are going to study about triangles. All right. So the topic that I've written down on your screens there is resolution of vectors into perpendicular components. But that's the main topic. So before I go to what does that resolution even mean, let me explain in brief what trigonometry is. Okay, these things are interrelated. All right, why trigonometry would be a natural thing to teach here? Because I told you about the triangular law of vector addition, isn't it? I told you how to add vectors. So it seems like you need to put them in a triangle. All right, that's how you add vectors according to the triangular law. So there is some link to this trigonometry that I'm going to teach you and the addition of vectors. All right. So let's see what is trigonometry. So let me consider a right angle triangle. So this works for a right angle triangle, and then we learn how to use this to any other kind of triangle. All right. So once we learn one thing, we can apply it to something else. So let's consider a right angle triangle. So let's call this right angle triangle as ABC, and it's right angle at the corner B there. Okay. So what would happen if trigonometry wasn't there? Would it be big difference? Yes. You bet. I think Yashwardhan, you asked me things about relativity, right? I can say that relativity wouldn't be there without trigonometry. I can go as far as saying that. Okay, we wouldn't be having a modern calculus without trigonometry. Okay, so to calculate the trigonometric ratios of small angles, very small angles, we kind of came up with calculus. So calculus wouldn't be there without trigonometry. If calculus isn't there, most of the physics wouldn't be there. Most of the engineering wouldn't be there. And you're mentioning general theory of relativity. Forget about general theory. You wouldn't have special theory as well. So very important stuff. Okay. Yeah. So suppose we have a right angle triangle, and I can consider any of these angles over here. I could consider the angle A. Let me consider the angle A. Instead of calling it as angle A, I'll be using the usual notation that we use in trigonometry class. We'll be referring to angles as theta's. Okay. So do not be scared. When I say theta, I just mean that angle A there. So nothing to be scared about. Just a Greek letter for T. theta. Okay. Now I'm going to define a few ratios. Now this might be scary because so far in mathematics they might not have used this terminology. Let's define something, right? Do the math teachers use that? So I'm going to define something. Okay. Okay. So the ratios are these: sine theta. Sine theta. It's actually there is meaning why it's called sine theta. So let me write it. The full word is sine. Okay.
So right now another one. I just know the name.
Okay.
Cos theta and tan theta.
Yes, we'll see what is cos theta and what is tan theta. Right now, these are
Cosec
just
theta.
right. So sine of the angle theta. Okay. So sine of the angle theta is defined as opposite side to the angle theta. So you look at what side is opposite to the angle theta. So the side that is opposite to angle theta is BC there. When I say side opposite to the angle theta, I mean the length of the side. Okay. So BC, the length of the side BC, divided by the hypotenuse length. Length of the hypotenuse. You know how to identify the hypotenuse in the right angle triangle, right? How do you identify? Because most right angle
Side
triangles.
opposite to the 90-degree.
Yeah. If yeah, can you tell me which is the hypotenuse over here, Sandra? DEF in the triangle DEF.
DEF, sir. The
DEF.
triangle.
It's the triangle that I brought here.
EF is the hypotenuse.
Yeah. So if this was the right angle, if that's the right angle there, the side opposite to the right angle triangle is called as the hypotenuse. Right? So hypotenuse basically is the longest side in the right angle triangle. And you know, longest sides are always opposite to the largest angles, isn't it? What is the largest angle in the right angle triangle? That's the right angle, it's at 90 degrees, isn't it? The rest of them should always be less than 90 degrees because there are two angles, right? How much is it? I mean, 90. If one of the angles is 90, the sum of the other two angles must be 90 as well, isn't it? So other two angles are smaller. So the sides opposite to them are also smaller than the hypotenuse. So here, sine theta is BC by AC. That's how I'm calling it. Okay, I'm calling the ratio of BC by AC as the sine of the angle theta. All right. So what is cosine of the angle theta? What do I mean by cosine theta? Cosine theta. How do I define this? Can you come up with a way? There are three sides in the triangle, so I want the ratios of these sides. What side by what side? Cosine theta. So cosine of the angle theta is defined as adjacent side to the angle theta. Adjacent. Adjacent means what? See, there are two adjacent sides here, of course. Adjacent means next to. Adjacent means next to. So here's the angle theta. Adjacent to theta, there are two sides. One is AB, another one is AC. Correct? So when I mean the adjacent side, I always mean not the hypotenuse, the other one. So AB is the adjacent side to angle theta divided by the hypotenuse, which is AC. The length of AB divided by length of AC. Cosine theta. Why is it called cosine? Cosine, complementary sine theta, actually, if I were to read it out completely. Cosine. Complementary. What are complementary angles? You know what are complementary angles?
Angles which add up to 90 degree.
Angles which add up to 90 degrees, isn't it? So here's theta for you. This is theta. Let's call this as alpha. Okay, let's call this angle here as alpha. Alpha is the Greek letter for A. So it looks like A also, no? Alpha. Right? What is the sine of the angle alpha? What is the sine of this angle alpha? Yes, Shreya, what is the sine of the angle alpha? What does sine mean? Always think like that. What does sine mean? How did we define sine? Your mic is off, Shreya.
Yeah, sir, I forgot.
Sine of the angle. A sine. How did we define sine of the angle? Yes, Sarvesh, how did we define it?
So we defined it as opposite side of the angle by the hypotenuse.
Yes, always remember that. Whenever I say sine of the angle alpha or theta or anything, I mean the side that is opposite to this alpha, which is what? AB divided by the hypotenuse. So you see, sine of the angle alpha is opposite, which is AB divided by AC. But what is theta and alpha? Theta and alpha are complementary angles, isn't it? Theta and angle alpha are the complementary angles, because if I add theta and alpha, what do I get? I get 90 degrees. So this is called cosine theta, complementary sine theta, because this is actually the sine of the complementary angle. See, AB by AC, the ratio AB by AC is the sine of the complementary angle. Look at that, sine of alpha, which is the complementary angle to theta, is AB by AC. So cosine actually means complementary sine. Okay, so cosine theta. But anyway, since we're talking only about theta, we can say cosine of the theta is defined as AB by AC. Then there is tan theta. How can we define tan theta? Tangent theta.
Opposite side by adjacent side.
Yeah, tan theta is defined as opposite side to theta divided by hypotenuse. So you might be wondering at this point, why am I defining things like this? What's the point of this all? You'll see in a while. Opposite side, tan theta is opposite side, which is BC, divided by the adjacent side, which is AB.
Tan theta is also sine theta by cos theta.
Yeah. Now you can see those relations now, right? Tan theta is also sine theta by cos theta. We'll see that. We'll see all those things. Okay. Now, how many ratios are possible in that triangle if you're going to define trigonometric ratios? These are ratios, by the way, right? Length divided by length, isn't it? We have learned that in the units and dimensions class itself. So, if you are going to define ratios, trigonometric ratios as side length divided by side length, how many ratios are possible? Can you think of the possibilities? Yes, Sandra, correct. How many ratios can you think of in the history? If I'm going to keep on adjusting different, different side lengths and go on defining ratios like this, how many possibilities can I think of?
I'm not sure, so.
Take a guess. When you're not sure, just take a guess and say it to me boldly. Yashwardhan, yes, correct. How many possibilities would you think of? Can you think of? I can do this. Look at that. Opposite by hypotenuse. I can do adjacent by hypotenuse. I can do opposite by adjacent. What else can I do? Neha, yes, you're right. Tripti, what else can we do? Yes, Sarvesh. Any other possibilities, or is this it?
Sir, I think it's this much only, sir. We can't do any more possibilities.
Okay. Anybody would like to correct that? There are 3 more possibilities. Only 50% of the job is done.
Hypotenuse by opposite angle.
Exactly. Take the reciprocal of all.
The
those.
inverse of all of the 3
Yes.
ratios.
Take the reciprocal of all of them. You got 1 more ratio there, no? 3 more ratios. I'm sorry. You got 3 more ratios. Take the reciprocals. So that's what we are going to do now. So I'm going to define something called as 1 by sine theta. But instead of calling it as 1 by sine theta again and again, we are going to give it a name. 1 by sine theta, from this day onwards, we are going to call it as cosecant theta. Cosecant theta. Okay. Now these accidents are, these names are not accidents. Okay. Not that these accidents are names. No. These names are not accidents. Like we are calling tangent theta. Secant, cosecant theta. These are words that you have heard before, isn't it? Secant. What is secant? What is tangent? You have heard these words before. So those words are not coming there by accident. But we are not going to discover why these words are coming. It's just that we are just going to accept it for now. So 1 by sin theta is cosecant theta, and that is nothing but hypotenuse by opposite side. Then the next ratio is secant theta. Can you guess what is secant theta? What is secant theta?
1 by cos.
Yeah. It's 1 by cos or hypotenuse by adjacent side. 1 by cos and cot theta. Cot meaning cotangent theta. Cotangent theta, that is AB by AC. Sorry, AB by BC. Reciprocal of tangent. I hope it's clear why we are calling it as co. At least that is familiar, right? Cosecant theta or secant theta. Cot theta, cotangent theta. Cotangent theta is actually the tangent of the complementary angle. Complementary angle is the what? Alpha there, right? If you look at complementary of alpha, sorry, complementary angle of alpha, what is it? Sorry, what am I saying? Tan of the complementary angle alpha, you'll see that tangent is defined as opposite divided by adjacent, AB by BC. Okay. So these are our ratios, trigonometric ratios. These are just names. These are just names to different ratios. Why are we talking about ratios? We'll see. Give me a moment for that. Now, I usually use a memory trick like which one is sine and which one is cos and which one is tan. How will you ever remember this? Avni, how to remember this? I'll say,
Yes, sir.
forget it conveniently. Forget about it. It's all right. Now, right after teaching, why do I say forget about it? Because sometimes even I have confusion and I remember it like this. I have this code with me, SOHCAHTOA. SOHCAHTOA. What is SOHCAHTOA?
So can I say?
Yeah.
So so is sine of theta. So O stands for opposite and H stands for hypotenuse. And in ka, C stands for cosine, A stands for adjacent side, and H stands for hypotenuse.
Okay.
And in TOA, T stands for tangent of theta or tan theta, O stands for opposite side, and A stands for adjacent side.
Yeah, SOHCAHTOA. All right, that's my memory trick. So sine theta, I always remember. Okay, SOHCAHTOA. Okay, what is sine now? Sine is opposite by hypotenuse. But you have to remember opposite to what? Opposite to what? That's what we need to figure out, right? Opposite to the angle, whichever angle you're talking about. Okay. So let's figure out some standard values of these trigonometric ratios. Okay. So the first thing that I'd like to talk about is let me write down the values over here. Sine of the angle theta and thetas. Let's figure out the values for different theta values. So let me do the easiest one first. Always start with the easiest one first. Suppose you have a right angle triangle in which one of the angles is 45 degrees. One of the angles is 45 degrees. What does that mean? What is the other angle then?
45 degrees. 45.
What do we call such such triangles in which two angles are equal?
Isosceles triangles.
Isosceles triangles. What do you know about isosceles triangles?
The
The two
base
angles are
angles are
equal.
equal, and the angles that are the sides that are opposite to the angles are also equal.
So these two sides have to be equal, isn't it? This is true about any triangle, not just the right angle triangle. So it is definitely true for a right angle triangle, right? So let's say this side is equal to some length A. That side length is A meters or A centimeters, whatever A, 6, 5, whatever that you want to put there, or 1. 1 would be simple, right? But let me not say 1 because you'll question me, why did I choose 1? So let me say some A. So if you're not satisfied with 1, you put your number, whatever that you want. So if that is A, this other side also, the side AC also would be A. That we can't deny because the triangle is isosceles. Now the question is, what is the hypotenuse, length of the hypotenuse? Why do I care about the length of the hypotenuse? Because I want to find sine of the angle theta. Let me call one of these angles as theta. So it doesn't matter which one, both are 45 degrees. So I'm calling this angle as theta. So what is sine theta? Opposite by hypotenuse. Opposite to what? Opposite to whichever angle you call as theta. So in this case, this is theta. We have theta over here. So the opposite to that side is AC. So we know the length of the opposite side, A, divided by hypotenuse, so ka to r, so SOH. So we need to find the length of the hypotenuse. How do we find the length of the hypotenuse, Sarvesh?
Yes, sir.
How do we find the length of the hypotenuse? Shriniket, how do we find this? Where's my friend Yashwardhan? How do we find this? Length of the hypotenuse. We know the length of the two sides. How to find the length of the hypotenuse?
So Heron's formula?
No. Heron's formula gives you the area of that.
The Pythagoras theorem.
Pythagoras theorem, Sarvesh. Pythagoras theorem. Right? Good, Rohit. Yes. So Pythagoras theorem. So let's use the Pythagoras theorem. We want the length of the hypotenuse there. So we know that the Pythagoras theorem says that AB square is equal to the square on the other two sides, which is A square, sum of the squares of two sides, which is A square plus A square. So this will come out to be 2A squares. We have 2A square there. So AB square comes out to be 2A square. I wanted AB, so AB would be, take the square root on both sides, you get root 2 into A. Root 2 into A. So we write that now. Square root of, in the 45-degree triangle, in the 45, 45, 90 triangle, the hypotenuse length is root 2 times the side length. This has to be, whatever the side length is, if it's 10 centimeter, if the side length is 10 centimeter, what would be the hypotenuse length, Sarvesh? Quickly. If the side length in the 45, 45, 90 triangle is 10 centimeter, one of the side lengths is 10 centimeters.
10 square plus 10, 100 plus 100. 200 square, which is 10, 2 root 10.
2 root 10. Is it 2 root 10? It's root 2 into 10. See? Root 2 into 10. A is 10, no? A is 10. So root 2 into 10. Or root 200, yes. Perfect. So in any right angle triangle, if you know the side length, you can figure out the hypotenuse by using the Pythagorean theorem. Now, what is the sine of this angle 45 degrees? What is the sine of the angle 45 degrees? Look at that. Opposite by hypotenuse. What does it come out to be? Sine of 45, let me write it over here. Sine of 45 will come out to be 1 over root. 1 over root. Okay. This is always the case. No matter how big the triangle is, if it's a 45-degree right angle triangle, then the ratios of the opposite side to the hypotenuse is always 1 over root. Which means that the hypotenuse is always root 2 times bigger than the what? Any of the sides. That's what ratios means, isn't it? You're comparing the lengths of one side to another side. So how big is the hypotenuse when compared to the side, opposite side? It is 1 over root 2. Okay, that's what it means, trigonometric ratios. There's no more meaning than that. At least
So how do we write that mathematically? Like sine of 45 equals to 1 by root 2?
Yeah, that's what we write it. We write it as sine of 145 degrees as 1 over root 2. That's the value. What about the cosine of 45 degrees? Let's extend this table a little bit. What is cosine of 45 degrees? Cosine. What did I say is cosine? Sine of the complementary angle, isn't it?
Adjacent side by hypotenuse.
Adjacent side by hypotenuse. If you're looking at this angle, isn't it? Cosine of the theta is adjacent by hypotenuse. That's one definition, isn't it? But what does cosine mean? You look at the sine of the complementary angle. So here's the angle, 45 degrees. What is the complementary angle? Okay, it sits right here, isn't it? This angle is always the complementary angle because when you add these two angles, you get 90 degrees, isn't it? So here's the complementary angle. What is the sine of the complementary angle? Again, this is sine 45. So look at that. Opposite by hypotenuse. You can see that it's opposite by hypotenuse. Or if that's too confusing for you, you just look at the sine cosine of the theta itself. You look at this angle itself. So adjacent divided by hypotenuse. So this will come out to be 1 over root 2 again.
Excuse me, sir.
Yes.
So cosine is the sine of the complementary angle, right?
Yes, exactly. Cosine is the sine of the complementary angle. That's it. So all you need to remember is one ratio basically, sine theta. Then you have cosine, which is the complementary of sine. Then you have tangent, which is sine divided by cos. Then you have cosecant, which is 1 by sine, secant, which is 1 by cos. So all you need to remember is sine theta, that's all. Nothing else needs to be remembered. Okay, what about tan theta? Tan 45, okay.
1.
Tan, yes, Savni, what is it?
1.
1. What does that mean? Meaning of that? So in the 45, 90, 45 triangle, the opposite side and the adjacent sides are equal in length, isn't it? So what is the ratio of those two sides? 1. They're both equal, isn't it? That's what it means. Tangent theta, opposite by adjacent, both of the sides are equal, therefore the ratio is 1. So you can see right here. You can see right here, both of them are equal to A. Opposite and adjacent are equal to A. So you get tangent theta is equal to 1. Okay, what was the other one? Cosecant theta. What was cosecant theta?
1 by sine theta.
1 by sine theta, right? So 1 by sine theta. What is cosecant of 45 degrees?
Root 2.
Yes. 1 by sine theta. Sine theta value we know, root 2. So cosecant theta is hypotenuse by opposite side. So I'm not going to talk about the secant and the cotangent theta. You know how to figure them out, right? That's your exercise. Okay, let's change the triangle now. 45 degrees is done. So let me first take an equilateral triangle. We'll see what to do with that. So here's the equilateral triangle. What does that mean, equilateral? Lateral.
All sides and angles are equal.
Yeah, lateral meaning lateral sides. Equi meaning all sides are equal, right? So we have an equilateral triangle. All the sides are equal. So let's say this is A, and this is A. So how to get a right angle out of this now? Just drop a perpendicular. Just drop a perpendicular from the vertex A there. So you know that in the equilateral triangle, the altitude is also the median, isn't it? What does that mean? Altitude is the median. Median means what?
It joins the midpoint and the vertex.
Yeah, it joins the midpoint of the opposite side to the vertex, isn't it? So median. Altitude means what? It's the height of the triangle. You basically drop the height of the triangle. So altitude and the median are the same thing over here in the equilateral triangle. So this is also the median, which means this line segment over there divides the opposite sides into two equal parts, A by 2 and A by 2. Is that okay? Okay, in the equilateral triangle, the altitude is the median as well as the angle bisector. What does that mean? You can see this clearly, right? I'm not proving it. I'm just leaving it to your intuition that this is 30 and this is 30. Correct? It divides equally. So in the equilateral triangle, you know that all angles are 60 degrees. So we have another triangle now. What to call this the triangle? This is the 30, 60, 90 triangle, isn't it? So we'll find the sine of 30 degrees. What does sine of 30 degree mean? Sine of 30. Sine of any angle. Shreya, what is the sine of 30 degrees?
A by 2 by A.
Yes, exactly. Good. A by 2 by A. The opposite side divided by the hypotenuse. So opposite side, which is A by 2 by A. Anirudh, not 2A by 2. Just A by 2 by 2. Sorry, A by 2 by A. So A by 2 is half of A, isn't it? Look at that. A by 2 is half of A. So we simply write ratio is 1 by 2. I'm doing this A by 2 divided by A. A by 2 is half of A, isn't it? So the ratio is half. I hope you're getting the meaning of this. In the 30-60 triangle, if you look at from the 30 degrees point of view, the opposite side is half of the hypotenuse. You can try it. In every right angle triangle, this is always the case. In every right angle triangle in which the angles are 30, 60 and 90. So what is the cosine of the angle theta? Oh, by the way, what is the height over here? What is the length of the height, AD? Sorry, length of the altitude, I mean. What is that?
So we have to find it through Pythagoras theorem.
Exactly, we'll have to find it through Pythagorean theorem. So Pythagorean theorem states that AB square, the square on the hypotenuse, is equal to the sum of the squares on the other two sides. I know the square on the I know the hypotenuse here, a square. I know BD square. BD is nothing. Sorry, this is not equal to this. Is sorry, not the plus sign. A square is equal to the BD is a by 2, but I have to square that entire a by 2. So a by 2 the whole square plus AD square. What is AD square? Let's keep it as we have to find it, isn't it? So what does this come out to be? AD square comes out to be a square minus a square by 4. A square by 4. I hope you understand why it's a square by 4. A by 2 the whole square, isn't it? So a square divided by 2 square. What is a square minus 1/4 of a square? A square minus 1/4 of a square?
3/4 of a square. 3/4 of
3/4 of a square.
3/4 of a square, right? So AD square is a square minus 1/4 of a square, which is 3/4 of a square. What we want is AD. So we take the square root on both the sides. So this will come out to be √3 into a divided by 2. Agreed? I've taken the square root. Yes, Yashwardhan, to that. So now I know the altitude. Altitude is √3a divided by 2. √3a divided by 2. Okay, again the same question. What is the cosine of the angle theta? Cosine of the angle theta now. Theta is this 30 degrees. Cosine of 30 degrees. SOHCAHTOA. Yes, Tripti, correct. Aishwarya, what is the cosine of this 30 degrees? Cosine of the angle theta?
I don't know, sir. 1/2, I think.
No, that's the sine of the angle theta. See, here's theta. Sorry, here's the theta. I'm asking, what is cosine by the way? Cosine. SOHCAHTOA, do that. SOHCAHTOA. Today you should get dreams of SOHCAHTOA. That's how much I'm going to say today. Let's look at that. Cosine is adjacent divided by hypotenuse. No, Aishwarya, adjacent divided by hypotenuse. So here's 30 degrees. I want to find the cosine of this 30 degrees. Right? So what is the adjacent side to that 30 degrees? Adjacent to this 30. What is adjacent? Adjacent means next to. Which side is next to this 30 degrees? Don't worry. See, there are only 3 sides there, isn't it? You can take a guess. Just take a guess.
80 degree.
Sorry?
80 degree.
What do I say?
80 degree.
80 degree.
Yes, sir.
No, I'm talking about the side length. See, here's the 30 degree. This is not 80 by the way, that is 30, okay? The side that is adjacent to 30 degrees. side that is adjacent to 30 degrees. What is adjacent to 30 degrees? Which is the side that is next to the 30 degrees? So there are two sides here, no? Which one's the adjacent side?
$60.
No. Adjacent side. Side that is next to 30 degrees. Not angles, not adjacent angles. Adjacent angles means what? Angles that are next to each other, isn't it? Okay, do you want me to change that word, adjacent? Let me say, what is the side that is next to 30 degrees? There are two sides over here that are next to 30 degrees, no? Which are those? See this one, Aishwarya, this side, look at that. AD and AB are both next to 30 degrees. But when I say adjacent, I mean always the other side, not the hypotenuse, but the other side. So I mean this, adjacent. This is the adjacent side. Okay. So cosine is the adjacent side divided by the hypotenuse. So length of the adjacent side is root 3 by 2 a, root 3 by 2 a divided by a. So that will come out to be root 3 by 2. What is tan of 30 now? Yes, Shreya, what is tan of 30? Tan of any angle theta. How is it defined?
A by 2 divided by root 3 A by 2.
Yes, exactly. Can you tell me, work it out and tell me what it comes out to be? You're right. Opposite by adjacent. Opposite by adjacent. What will that come out to be? Tripti, yes. Tripti, go ahead and figure out 60, sine 60, cos 60, and tan 60. Rohit, small mistake, Rohit. You messed up the ratios. You're talking about tan of 30, right? You messed up one little thing. That's try to figure it out.
So is it 1 by root 3?
It's 1 by root 3. Rohit, it's 1 by root 3. Okay, just to check it out. 1 by root 3. So tan of 30 is 1 over root 3. Tan 30 is.
I wrote it correct, but while typing, I messed it up.
Okay. So tan 30 is opposite side, the length of the opposite side, which is 1 over a over 2, divided by the length of the height, which is root 3 by 2a. Now these are fractions, you know how to deal with them. So a by 2 into, you take the reciprocal of this, 2 divided by root 3a. So a and a gets cancelled there. 2 and 2 gets cancelled, and you have 1 over root 3. Okay, now 60 degrees. Figure out the, I'm leaving the other things out because they're simply the reciprocals, isn't it? You found the, Yashwardhan, you found the trigonometric ratios corresponding to 30 degrees. Now you find it for 60 degrees. I hope you remember what the side lengths were. So this was a by 2, this was root 3a by 2, and this was a. Now find the sine of 60 degrees. What is the sine of 60 degrees? It's the cosine of the 30 degrees, no? Sine of 30 is the cosine of, sorry, sine of 60 is the cosine of 30. Agree with me? You can see for yourself, just try it out. Sine of 60 is the
Yes,
cosine
sir.
of, yeah, that's what I meant by complementary, right? So you can check it out over here, or you can just trust me. Sine of 60 is cosine of 30, which is half. Sorry, root 3 by 2, I'm sorry. Sine of 60 is cosine of 30, which is root 3 by 2. What is cosine of 60?
Half.
Sine of 30. Yeah. Sine of 30. What is tan of 60?
Reciprocal of tan of 30.
No. I knew somebody would say this, yes. This was all a trap for you. Is it? Is it reciprocal of tan of 30? Or am I trapping you? Trap or no trap? Is Rohit Azra, is this a trap?
Is it the cos of 30 degree?
Sir, I
Sorry,
don't know. It's confusing. Trap or not?
Okay. That's the point of the trap, no? Rohit Jevita.
So you admit it is a trap.
No.
So that's not you told. That's the point of a trap. That means it is a trap.
No.
Sir, you did.
I said traps are like that. That's the nature of the traps, I said.
Yes, sir. But your words meant something else. Your exact word meaning was different entirely.
Yeah, that's how traps are usually.
Sir, it's root.
Words. Yes,
Sir,
Rohit.
it is the reciprocal.
It is the reciprocal, no?
It is the reciprocal, isn't it? Yes. So tan 30. It does not work in the general case, by the way. It's working over here. So tan 60 is the reciprocal of tan this one. But look at tan 60. Tan of this 60 degrees, here 60 degrees. Tan of 60 is opposite divided by adjacent, isn't it? Opposite is root 3a by 2 divided by a by 2. So
Sir,
root
is
3
it
a by
always
2
the reciprocal of
is
1 by 3?
reciprocal of 1 by root 3.
Yeah, root 3. Always or some cases? Special
In
cases.
this case, yeah, in this case it works out. See, always this is true. Tan theta is always the reciprocal of cot theta. Okay. Here it worked because of that thing only, right? Because tan 60 is nothing but reciprocal of, sorry, tan 60 is actually what? What is tan 60?
Root 3.
Root 3.
No, sorry. Tan 60 is actually complementary angle of cot 30, isn't it? Tan 60 is complementary of cot 30. What is cot 30 here? What is cot 30? Cot 30 is 1 by root.
Root 3.
Sir,
Root 3.
tan 60 is equal to cot 30, right?
Yes, tan 60, that's what I meant to say actually. Tan 60 is equal to cot 30. In this very specific case, 30 and 60, it works out. But in any general case, you cannot take the this one, reciprocal of the other angle and say that it's working. Only in the complementary case it works. So tan 60 is root 3 a by 2 divided by a by 2. Root 3 into a by 2 divided by a by 2. What remains? A by 2 gets cancelled. What remains is root 3, isn't it? So that is tan 60 is root 3. Okay. Now,
Excuse me, sir.
yes, Sarvesh.
But like, how did people find it out about the trigonometry thing? And how did they know that it's gonna be useful somehow?
No. We do not think about mathematics like that. That's the wrong impression that you might have about mathematics. Okay, it's like somebody sits in his room and says, "Let us define sine theta as opposite by hypotenuse and all those things, and let's see where it is useful." No, it's not done like that. No mathematics is done like that. First, you're out in the world. You observe things. Okay, how do I calculate the height of the mountain? The sad part is, even I have to stick to this, that I'm teaching you, okay, let us define trigonometry ratios like this and see what happens. That's not how it goes. You are out there in the world, you're trying to figure out the height of the building. How do you do it? How would you find the height of the building without actually taking a measurement from the ground to the top of the building? See, that's the kind of questions that are asked to geometers and these people. And this is the answer that they come up with. Okay. So the first guy who did it, he did not do this first and saw the usefulness of it later. He did it because he needed badly to come up with some way to discover to find the heights of buildings or find the height of the mountains. See, how do you think they know the height of the mountains? This mountain peak is this high above the sea level and all these things. Of course, they're not really measuring it. They're not using trigonometry there when you have 2 kilometers and all those things. But if you have a building far away from here, how do you figure out the height of the building? Question also becomes, why do you need to find the height of the building? So to those people to whom those questions are relevant, they need to find out somehow, isn't it? Yeah. Where was I? Yes. So we found the trigonometry ratios of 30, 45, and 60. What other angles are remaining that you think are important? Some strange reason.
90, 180, and 360.
Yeah. So how do you have 180 degrees in a triangle? How can the angle be 180 degrees in a right angle triangle? By the way, there are ratios of trigonometry. Trigonometry is extended to all the angles, 180, 240, 270, whatever you can think of. But right now we'll be sticking only to these 0 to 90 degrees, okay? All right, sine of 90 degrees. So Tripti, what is the sine of this 90 degrees? Where is the 90 degrees, by the way, in the right angle triangle? So let's say this is theta, this is alpha. What is the sine of 90 degrees? Sine of any angle is what? Opposite by hypotenuse. Right?
1.
It's 1. Who said that? So 90 degrees is over here. Sine of 90.
1.
Yeah, it's the opposite side to the hypotenuse. Opposite side is the hypotenuse, so 1. Sine of 90 is 1. Cos of 90. Now this is the trickiest one. What is cos of 90?
So can cos of 90 have two values?
Cos of 90?
Have two values?
Yeah, that's what it looks like. No, it has two values.
Yeah.
No.
Okay.
Anirudh says also says cos of this 90 degrees has two values. See, in mathematics, whenever I said definition, you cannot have two meanings. So you should not be in a confusion. Okay, so said adjacent by hypotenuse. But in the case of cos 90, we seem to have two adjacent sides. So which one is it? Do we go about it as we like? This time I like to call BC to be the adjacent. Next time I feel like AC to be the this one. Not defined. Is it not defined?
Sir, if it is an isosceles triangle with a 90 degree, and if you're finding the cos for that, then it will be same.
No. Actually, no. Sin 90 seemed to be the easiest thing. This is the hardest thing, right? This is a good point to be stuck at actually, because we did everything and now it seems like, okay, doesn't make sense.
Sir, we know that, is it because 90, like the complement is 0 degree, so we find like sine of 0 degree, but...
Very good. That's the first thing I told you, right? Sine is nothing but complementary of this one. But what is sine of 0? Let's go to that. I can accept that point. Okay. What is sine of 0? Where is 0 degrees? How can you have 0 degrees in a right angle triangle?
There can be no triangle made with 0 degrees.
Are you sure about that? Let me draw you a triangle with the angle 0 degrees. Do you see that? What is that?
How is that a triangle, sir?
It is. So, do you agree that this is a right angle triangle? Okay, that's a right angle triangle there, right? So let's call this angle over here. I'm sorry if I've, yeah, let's zoom that in, yes. So let's call this angle over here as theta. So the triangle is ABC, okay. The triangle is ABC. So that's our theta there. Theta is tiny, okay. So it's so tiny that it looks like AB is overlapping with AC, okay. AB seems to be overlapping with AC. Now, what is the sine of this angle theta? They are very, very close. AB is overlapping with AC. You can imagine that, right? So, what is the sine of this angle theta? Theta is what? Theta is 0. It's approximately 0. What is it? Or how is sine of any angle defined? We use the same definition.
Opposite side by hypotenuse.
AC by
Opposite
BC.
side by...
Sorry, AC by AB.
AC by...
So we can take both AB and
AB.
BC because...
Yeah, we can take both AB. Yeah, that's very nice. We can take both AB and AC because they're going to overlap, isn't it? They're going to overlap. So it doesn't matter. But let's stick to our definition. So AC divided by AB. But we can say that AB and ABC are the same things over here. What does this ratio come out to be? Look at that. AC is nearly 0, isn't it? The opposite side is nearly 0. See, when theta is equal to 0, now theta is not 0. You ask me, how can this be a triangle, right? It's a very skinny triangle. Skinniest of the skinniest triangles. That is theta is equal to 0. Okay. Now you can see that AC is equal to 0. AB is not 0. AB is some length. I don't care what it is. It's some big length. So what is sine 0?
0.
0.
0. Sine of 0 is 0. So sine of 0 is 0. What is cosine of 90 then?
0.
Cosine of 90 is 0. Why? Cosine of 90 is the complementary of sine 0. Sorry, 90 is nothing but complementary angle of this angle 0. So we get cosine of 90 is 0. How do we justify that in this picture? How do I justify that in the picture? Where is cos? Look at that. Here's 90 degrees, right? This is 90 degrees. Agreed? This angle over here, the angle at the corner C is 90 degrees. Whatever. Now look at the cos 90. What is cos 90?
Sine O.
Sorry, cos 90. Sorry. Yeah, sine by our own definition, cos 90 is, yeah. See, cos 90, use the old definition itself. What is cos 90? Adjacent by hypotenuse, isn't it? Adjacent by hypotenuse. So here's your 90 degrees. What is the adjacent side? There seem to be two adjacent sides again. Which ones are those? AC and BC, isn't it? But I told you one thing. Adjacent side is always going to be the hypotenuse on one side, but we do not call the hypotenuse as the adjacent side, isn't it? We don't call the hypotenuse as the adjacent side. So, one second. Cosine is adjacent side. Yeah, sorry. There are two adjacent sides. I'm sorry. There are two adjacent sides to this angle 90 degrees. One is AC and another one is BC. Right? But BC we are not going to call it as what? Adjacent side. Why? Because when theta becomes 0, see when this angle becomes 0, right? That BC is going to be the hypotenuse, isn't it? BC itself is going to be the hypotenuse. So adjacent side here is going to be AC divided by the length BC. AC divided by BC, but AC we already know is 0. So AC divided by BC will also be equal to 0. All right. So cos of 90 is 0. What is sine of 0? Oh, sorry, cos. What is cos of 0? What is cos of 0? This is one thing that is.
So 1, because it's
Cos
sine
of 0 is 1. Yeah, complementary. To make peace with that, you have to revisit that diagram. Look at that tiny diagram that I've drawn there. Cos of 0. So in that skinny triangle, this is 0. So adjacent by hypotenuse again. So when the angle is 0, adjacent and the hypotenuse are the same thing. Look at that. Adjacent side and the hypotenuse are the same thing. So cos of 0 comes out to be 1. Okay, what is tan 0? What is tan 0?
cot 90. Cot 90.
What is cot 90? So you can do it over here, right here. Look at that. Tan 0. Tan 0. Tan 0 is opposite side divided by adjacent side. What is the opposite side? 0. Opposite
BC
side
by
is 0.
AC, right?
Yeah. No. Opposite side to 0 divided by adjacent side to 0. Opposite by adjacent.
Oh, yes, sir.
So cut over, right? Opposite side is AC to 0. This is 0. Opposite to 0 is AC divided by BC. So AC by BC is what? AC is 0 divided by whatever BC is. So tan 0 is 0. Tan 0 is 0. So you can see it over here as well. So tan theta is sine theta by cos theta, isn't it? Tan theta is sine theta by cos theta. So 0 by 1, which is 0. Okay, what is tan 90? Tan 90, you can see over here, 1 by 0. 1 by 0. 1 by 0 is not a number that we can think of. Undefined. At least not a real number. As opposed to what? Fake numbers? What do we mean by real numbers? Okay, these are the ratios. All right. Your job is to find cosecant theta, secant theta, and cot theta. So once you've got this table, we'll do something useful with this table. Okay, problems. A car travels 20 km due north, towards north. Then 35 km in the direction 60 degrees west of north. Oh my God. West of north. Find the magnitude and direction of the car's resultant displacement. How to do this?
So, sir, we use trigonometry to find displacement of.
Why? Just because the previous topic was trigonometry, why do you think you have to use trigonometry to do this?
So we can
No,
use Pythagoras theorem.
Yeah, you could use Pythagoras theorem. No? So car travels 20 km due north. So here's your starting position. That's the starting position of the car. 20 km due north means what?
Towards north.
Towards north. So we start from this point. This is the starting point. For some strange reasons, we call the starting point as O. And we are going 20 km to the north.
Sir, can be there, sir. O stands for origin.
Yeah, it stands for origin. I know. It's just that.
I guessed, sir. I never thought it should stand.
Yeah. It is origin actually. Origin meaning the starting point. That's why origin is called origin, because it's the starting point. Origin in the coordinate system. So this is 20 kilometers northwards. That's the first displacement. Let's say this point is A. So we're going from O to A. And 35 kilometers in a direction 60 degrees west of north. How do you go west of north? How do you understand that? West of north.
Left. 60 degrees towards the left.
60 degrees towards the left, is it? West of north. We are going 60 degrees west from the north. We would have gone northwards, but we are going 60 degrees west of north. Okay, so this is the north direction. From the north direction, you have to go towards the west. By how many degrees?
60
60.
degrees.
60 degrees, right? So this is the north direction. So from the north direction, you go 60 degrees west of north. West means to the other side. So let me give a marker over here. So this is north. To the right is the east, and to the left is the west. So we're going 60 degrees north of west. Find the magnitude and direction of the car's resultant displacement. Okay, I'll need to write a proper diagram now. 1 second, I'll do that. So let's call this point as B. So resultant displacement, how do you find the resultant displacement? Join O and B, isn't it? Join O and B, that's it. Join O and B there. Is that okay? This is the resultant. Do you all agree? This is the resultant displacement. That's the total displacement, you can say. Can we apply Tripti, the Pythagorean theorem? To apply the Pythagorean theorem, we'll need a right angle triangle.
Right angle triangle.
Do we have a right angle triangle?
No, sir.
Can we get a right angle triangle? Can we do some mathematical trickery to get a right angle triangle? Because we have one tool in the toolbox, isn't it? What is that? The Pythagorean theorem. To apply the Pythagorean theorem, we'll need a right angle triangle, which we don't have. Can we get it?
It depends on the angles. If angle B and O are equal, then yeah.
No. 1
We
second.
could draw an altitude from A to R.
A to
right
one second,
angle.
let me write a proper diagram for you so that I'm drawing the same diagram by the way. So we went from O to A. O to A. This was 20 kilometer. And from A to some B. And we went at 60 degrees. 60 degrees north of west. Sorry, west of north. And we are interested in finding this resultant. We are interested in finding the length of that side OB. The thing is, we have one tool in the toolbox, Pythagorean theorem. We don't know how to use it because this is not a right angle. So I'm saying let's get a right angle triangle without changing anything, of course. We should not change the problem, right? So you can't ask whoever the car travels. You can't ask the car not to go at 60 degrees west of north. Go perpendicular, then I can solve this problem. Can't change the problem. How to get a right angle triangle here? Sandra, you were saying something.
Sir, I was saying that we could like draw an altitude from A to OB and get two right angle triangles.
A to?
But then OB.
Okay. Okay, so you're saying let's draw a line from here to here, right?
But then I was like, what to do after that?
But so we need an equilateral triangle for that.
Yes,
right?
sir.
Why do we need an equilateral triangle? Oh, you mean for this to be divided equal, is it?
Yes, sir.
Yeah.
I didn't say anything like that. I was just thinking about it. But then if you do that, I don't know what to do after it.
Yeah, there is, even I can't think of anything to do after that. Because we don't know those, even if you divide it like that, we don't know those other sides. No?
So we could draw a perpendicular from B to OA, so we'll have an exterior.
Yeah, look at that. We can drop a perpendicular from B to OA. What just happened there? If I drop a perpendicular from B to OA, do we get our
90 degree?
We get
30,
a
60, 90 triangle.
Yeah, 1 second. Let me do it properly here. Did we get a right angle triangle? Where is a right angle triangle? See, this is a right angle triangle, right? That's a right angle triangle. Do you see that? So if you get a right angle triangle, then what do we have to do? We have to apply the Pythagorean theorem, isn't it? To apply the Pythagorean theorem, what do we need? We need to know the length of this base. We need to know the length of this base, and we need to know the length of this height over here, the height value, isn't it? Do we know any of those things? No. We know half the information. We know that this length AO is equal to 20, right? We know that. We know this AB, it's 35. I forgot to write it, but it's 35, given in the problem itself. That is 35. Can we find this AD? Can we find AD?
We could use trigonometric ratios.
Yeah, trigonometry ratios, right? How can we use trigonometry ratios? This is 90 degrees. That's 90 degrees there. So this is 30, 60, 90 triangle, isn't it? 30, 60, 90 triangle. And what do we know about the 30, 60, 90 triangle? In the 30, 60, 90 triangle?
We know that the sine of 30 is 1 by 2.
Yeah, what does that mean? What does that mean?
That is adjacent side by hypotenuse will give us 1 by 2.
Yeah. So sine 30 is 1 over 2. Sine 30 is 1 over 2. What that means is the opposite side to 30, in a 30, 60, 90 triangle, this opposite side to 30 degrees must be half of the hypotenuse, isn't it? See, let me write that again. So sine 30 is equal to 1 over 2. Sine 30 is 1 over 2. But sine 30 means, sine means what? Sine means opposite by hypotenuse. Sine means opposite by hypotenuse. So in the 30, the sine, the opposite to opposite by hypotenuse, okay, the opposite side to 30 degrees divided by the hypotenuse should be equal to 1 over 2. So hypotenuse should be twice as bigger than the opposite side. Correct? So what can you say about this length AD? Shreya, what is the length AD? What should be the length AD? I know the hypotenuse. Hypotenuse is 35. What should be AD? Yes, Tripti, correct. Yeah. Anirudh, what is AD? In the 30, 60, 90 triangle, this the side opposite to the 30 degrees is half of the hypotenuse. That's what sine 30 is equal to half means. Hypotenuse we know, 35 degrees. What is AD? The opposite side to 30 degrees is what I'm asking. Yes, Anirudh? Did you say something? I can see. Avni, yes, correct. Yeah. No? Neha, what is it?
17.5.
Yes, it's 17.5. Half of 35. Otherwise, half of 35. 35. Correct? Anybody has a doubt over there? Just ask me. Anirudh, Shreya, are you in doubt?
Yes, sir, I have.
Did not understand what I said there?
Yes, sir.
In any 30, 60, 90 triangle, in any 30, 60, 90 triangle, not just this one. What do I mean by any 30, 60, 90 triangle? How can there be many? There can be only one 30, 60, 90 triangle. Isn't it? You can have any number of 30, 60, 90 triangles, by the way. So these are called similar triangles, isn't it?
Yes, sir.
So what do you know about similar triangles?
The shape is similar.
The shape is similar. So if these two triangles are similar, what can you say about the ratios of their sides?
The ratios of their sides are equal.
Ratios of the sides are equal, isn't it? So you take any combination of their corresponding sides, of course, they have to be equal, isn't it? So if I pick out uh, opposite by hypotenuse over here, opposite by hypotenuse in this triangle, this is the 30, 60, 90 triangle. The opposite by hypotenuse over here must also be the same, isn't it? Right? Because the ratios have to be same. Right? Now, before, when I was doing that, I had discovered this fact. So if this is 30, if that is 30, then sine of that 30, sine of any angle, not just 30, sine of any angle is defined as opposite by hypotenuse. Remember that? So cut over, isn't it? And we found that sine of 30 is equal to half. Sine of 30 is equal to half. What does that mean? It means that the opposite side is equal to take the length of the hypotenuse to the other side. Opposite side is equal to half of the hypotenuse. Okay, this is true in any 30, 60, 90 triangle. All right. In the problem, we have one specific 30, 60, 90 triangle in which the hypotenuse is 35 degrees. All right. So here, the opposite side to 30, the opposite side to 30 must be like in any triangle, 30, 60, 90 triangle, should be half of the hypotenuse. Right? Yeah. So now I know the base. I know the length of the base now. What is the length of the base? The length of the base we know, we found out. That was the problem there, isn't it? We did not know the length of the base. Now we know the base, that is 20 plus 17.5. That is 37.5. Again, the problem is not done. I have to find the hypotenuse. I want to find the hypotenuse. So what else do I need to find to find the hypotenuse? Registry, take a guess. Do not be afraid. Just take a guess. What else do I need to find now?
So what was the question?
To find the Pythagoras, that's not the Pythagoras. To find the hypotenuse, what else do I need to find? I found the base there, isn't it? I found the length of the base.
The other side, opposite to
The other side, yes. The other side. How do you find the other side? How to find the other side? Notice that the other side is opposite to 60 degrees or adjacent to 30 degrees. Right? You can say it's opposite to 60 degrees or adjacent to 30 degrees. So what to do? What do we know? Sandra, yes, we could do that. So we know that sine of 60 degrees is root 3 by 2 in any triangle, in any right angle triangle. Sine of 60 degrees is root 3 by 2. Sine of 60 means what? Sine of 60 means opposite to angle 60 divided by the hypotenuse. This is equal to root 3 by 2. So I want to find the opposite side over here, opposite to 60 degrees, I mean. So opposite to 60 degrees is equal to root 3 by 2 into the hypotenuse, whose length I know, 35. Is that okay? So now we get the side length over here. This is 35 into root 3 by 2. Could we have used some other ratio to do that? Could we have used some other ratio?
Cosine 30.
Cosine 30. Could we have used some other ratio? What about tan 60? What is tan 60?
That's 1 by root 3, right?
Tan 60 is root 3.
Oh, root 3.
Can we use tan 60? Tan of 60 is what? Opposite, which is what we have to figure out, divided by the adjacent side. Can we use that? Because we know the adjacent side now, isn't it? 17.5, you see? 17.5. So we can figure out the opposite side. So you can try out any other combination like that. It's not like you have to always stick to sine and cosine. Sine and cosine will come out naturally, so we use that. Okay. You experiment with that one. Okay, now we know everything that we need to know to find that magnitude, isn't it? So how do we do this? Yes, let's go for it. So the Pythagorean theorem says that OB squared is equal to OD squared plus DB square or BD square. OD square plus BD square. So OD squared, what is OD squared? OD square, that is 37.5 the whole square plus BD square, that is 35 root 3 by 2 the whole square. What is 37.5 the whole square? Oh my god, that's a mess, no? 37.5 the whole square.
So 1406.25.
2406.25. Sandra says it's 1406.25.
Thousand, sir.
Ah, okay. I'm going blind in this year. Okay, 1406.25. Okay. Plus 35 root 3 by 2 the whole square. 35 square. What is 35 square? $12.25. How did you do that, Sandra?
So there's this trick to find the squares of any like 2-digit number or any number which has 5 as their last digit.
Yeah,
So for 35 you have 5, so square 5, so the last 2 digits will be 25.
Yeah.
And then you have to do 3 into 4, so 3 plus 1, and you multiply it, so you'll get 3 into 4, 12. So put that there, so you'll get 12.
Yeah, it's called Ekadikena Purvena. Sanskrit for add 1 to the previous number, multiply. So 35 into 35. So those of you did not understand what she did there. 35 into 35. So if the numbers end in 5, so multiply 5 and 5, 25. Then add 1 to the number over here, 3. 3 plus 1. Okay, that would be 4. 4 into 3 would be 12. Doesn't work all the time, by the way. You can do 34 into 36. 6 into 4, 24. 3 plus 1 is 4. 4 into 3 is 12. 1, 2, 2, 4. You can try it out.
Sir, but it always works with numbers which end with 5.
Does it work in this case? 75. You're talking about squares, right? I'm talking about multiplication.
No, I'm talking about squares.
You're talking about squares. So if you're talking about multiplying these two numbers now, 75 into 65, it will not work. So the condition is these two numbers have to be same, and the end numbers have to end in what? 10. So 5 plus 5 is 10. 4 plus 6 is 10. So if that condition is satisfied, then it will work. Okay. Anyway, so 35 into 35 is 1225 into root 3 squared is 3 divided by 2 squared, which is 4. What does this come out to be? 3/4 of 1225. 3/4 of 1225, that's around 800, isn't it? 806, 806.25. Is it right? $918, is it? You don't have the calculator here with me. 3/4 of 1200. What is 3? This is how I did it. 3/4 of 1200. What is it? No, I made a mistake. Yes, you're right. You're right. It's 900. I made a mistake. 3/4 of 1200 is 900. Then there is 25. 3/4 of 25 is 18.75. So it will come out to be 918.75. Yes, you're right. So this is 1406.25 plus 918.75. So 0.25 plus 0.75, that is 1. We'll keep that in our mind. 1406 plus 918. I'm going to copy your answer 2325. Is it?
Yes, sir.
2325. This is OB squared. So OB is equal to square root of 2325. Okay, we're not going to do anything better than that. Let's keep it as it is. Whatever square root of 2325 is. It's okay to keep the answers like that in the radical, this one form, square root form. It's okay. So we found the hypotenuse over here. It is square root of 2325. Okay. So now you know, even if you do not have the right angle triangle, how to get a right angle triangle, isn't it? You know the Pythagorean theorem. Even if they have not given you this one, a right angle triangle, you can get a right angle. Right. All right. There is one more question over here. I wanted to think about it. I did the half part of this question. Find the magnitude is what I said. There is direction of the car's resultant displacement as well. We have not found the direction, isn't it? Direction. What do I mean by direction? How many degrees north of west is it? So you can see that the displacement, resultant displacement is north of west, isn't it? Sorry, west of north. Resultant displacement is west of north. We know that. But by how many degrees is it west of north? How do we find that piece of information? Yes, Sandra.
I'm not sure if I'm right. I'm just guessing.
Yeah. Okay.
I was thinking about the angle BOD or
angle
O.
Let's call it as theta. Okay.
Angle theta.
Okay.
And using trigonometric ratios itself, but I'm not sure how exactly it works. I've just heard about it. So we know that sine of theta should give us 35 root 3 by 2 divided by root 2325. And if sine is like multiplied to theta, you could divide it by sine and do something like that?
No. You cannot divide by sine. Sine means what? Sine is the code for opposite by hypotenuse, isn't it? You can't divide by sine itself. What does it mean to divide by sine? It means nothing, no? Can we divide by sine? That's not a number. You can't divide by sine. What to do? Your idea was perfect, Sandra. See, this
If
is
we
why we need to develop.
simplify the ratio, would
Can we
get
simplify that
some-
ratio?
we could get something close by.
So sine theta, look at that triangle. Look at this right angle triangle over here. Look at that right angle triangle. I'm interested in finding the theta, angle theta there, isn't it? So what Sandra suggested is use sine theta, because sine theta would be opposite. Theta, we do not know what it is. But sine of that angle theta, whatever the theta is, it is 35 root 3 by 2 divided by the hypotenuse. What is that hypotenuse? 2335. The square root of 2335, 2335, isn't it? Now, can you tell me the numbers? We'll need to find the decimal numbers here, because this is not any of those standard angles that we have seen, isn't it? Standard angles, we know what to do. What do we do? If it is 30, we know what the ratio is supposed to be. If it is 60, then we know what the ratio is supposed to be. Can you tell me this in the decimal form? What does this number come out to be? Sine 35 root 3 by 2 divided by square root of 2335. Use the calculator. You can't do it in your this one.
$30.31, I guess, approximate.
Which one? Square root of 2335?
No. 35 root 3 by 2.
35 root 3 by 2 comes out to be 30, is it approximately?
30.31.
30.31.
30.31.
Okay, we'll take it as 30. All right, approximately.
Root 2325 is 48.
Root?
Very close to 48.
Very close to 48.
Yes, sir.
Okay. So look at that ratio, 30 by 48. What is 30 by 48? Sine of 30 by 48 goes in the table of what?
It goes in the table of 3.
Goes in the table of 3. Okay, that is 10 by what is it? 16, is it?
0.
Yes, sir, 16.
Around 0.6, somewhere near there.
5 by 8. 5 by 8 is the simplified.
5 by 8. Yeah, that would be nice. 5 by 8. 5 by 8. 1/8 is how much? 1/8 is 0.125, isn't it? So 5 times 0.125. How much will that be? 4/8. What is 4/8? What is 4/8? 4/8 is nothing but half.
Half.
Then we have 1/8 plus 1/8. 4 by 8 plus 1 by 8 is 5 by 8, isn't it? So 4/8 is half plus 1 by 8. 1 by 8 is 0.125, isn't it? So 0.5 plus 0.1.25. That will come out to be 0.625.
625.
Yeah, 0.625. So we are looking at this triangle now. Sine theta is 0.625. So what is theta? That's what we are looking for, isn't it? So we're looking for a triangle. We are looking for a triangle in which the ratio of the opposite side to the hypotenuse is 0.625. So what should be the angle in the triangle? We are looking backwards now. It's a hard problem because we have to look backwards. Looking backwards is hard. Can we go to our table and try to guess what that angle should be? Guesswork. Right now we have to do the guesswork. See, this is the answer actually. Why was calculus invented? To find these kind of problems.
Sir, I'm thinking it should be close to 30 degrees.
It should be close to
30, maybe more than 30.
Yeah. 1 by 2 is what?
0.5.
0.5. 1 by root 2 is what? You can try it. 1 by root 2. Should come around 0.7 something. Should come around 0.7. 0.71 if I remember correctly. 0.717. 1 by root 2. Let's write 0.7. So can you guess where the sign value is? So 0, 0.5, 0.7, this will come out to be 0.8, around 0.8, and this is 1. So you see how the sign values are increasing. So our angle, which is 0.6125, is coming somewhere between 30 and 45, isn't it? It's coming somewhere between 30 and 25, and it is closer, sorry, 30 and 45. It is closer to 45 degrees, this value 0.6125. That value is closer to 45 degrees than it is to 30 degrees, isn't it? So it should come, even if your best guess is exactly in half, that is also fine. Exactly in half, exactly in between 30 and 45, you can say that. What is the value that is exactly between 30 and 45? 37.5, right? So you can take a guess like that. It must be around 37.5. It's okay to take guesses. Actually, it's slightly greater than 37.5. You can say 38 or 39. Okay. So don't worry much about that problem. It's okay. You can stop right here. You can say that theta is approximately equal to 38 degrees. So the direction of the resultant vector is what? 38 degrees west of north. 38 degrees west of north. So theta is equal to 38 degrees west of north. One second. Yes. Find the sum of the two vectors A and B. Find the sum of the two vectors A and B lying in the xy plane, and these vectors are given by 2.0 I cap plus 2.0 j cap, and B is that. So the registry is asking me, could you ask everyone to send their name and their number in the chat so that she and Avni can take a screenshot. How will you take the screenshot? Yes. Those of you are willing, you know what to do.
Sir, the chat is different. You have
So
to
the chat is only to the host now.
only
Yes,
to the
sir.
host and co-host. Make it for everyone so that we can. Otherwise, we can't.
I don't know how to do that. Yes.
So what should we do?
No, you don't have to do anything. They are asking if they could have the number and your name so that they can take a screenshot. So when I finish with this, you can do that, okay? They want to put in a group. Anyway. Wait, Rohit, not right now, wait. Yes, find the sum of the two vectors A and B lying in the xy plane given by those two vectors there. Sum of the two vectors. How do we find the sum of the two vectors? Has it got anything to do with the trigonometry or Pythagorean theorem?
No.
No.
Sir, did you put this question purposely to confuse us?
Not to confuse you, to remind you that you don't have to think in one line. It's like I'm not putting that thing in your. That's what they do to the horses. No? They put those things so that the horse cannot look that side and this side, so that it goes straight wherever you turn its neck. I don't want to
Yes, sir.
that to happen to you, because once I teach trigonometry, you think, okay, only trigonometry now. No. So find the sum of the two vectors. Those are the two vectors. Yes, Sanchita. Sanchita, what is the sum of these two vectors? Oh, Tripti and Sandra producing the answers. Shreya, try not to look at the answers. Just tell me what do you think is the answer there. A plus B vector. Shreya, you're afraid to answer. That's the problem. So the thing about answering is, the more you answer, the likely you are getting to likely you are to get it wrong. But it's okay. So if you don't answer, I'll keep on asking you, Shreya. I'm like a pest who keeps on asking the same person. Yes, A plus B. How do we do that? Let's draw it up. What does A look like? What does vector A look like? 2i plus 2j. 2i plus 2j. So vector I is 2 steps to the east, I can say. 2 steps to the east. And 2 steps to the north. This is the vector sum of those two vectors is the vector A. Now we have to add to vector A, vector B. What is vector B? So we'll start writing vector B from this point. It is 2 steps eastward, 2 steps eastward, and 4 steps downward. So from here you come 4 steps downward. Downward, I mean when I see that whenever I see the negative sign, for me that means downward or opposite. So this is the B vector. That is the B vector. So here's your A vector. This is your A vector, and this is your B vector. Add them both. How do you add the vectors? You complete the triangle there. So this is A plus B. Now I didn't really have to draw this diagram, right? Because now if you look at it, in the diagram it will be more clear. So if you look at this picture, you are going a total of 4 steps forward. Look at that. You're going a total of 4 steps forward along the east direction. Right? And how many steps you are coming down on a whole? You're going 2 steps up, but you're coming 4 steps down, isn't it? So how many? What is the total number of steps that you come downward? Look at that. From here, you go 2 steps down, isn't it? That's the resultant, you see. So the resultant A plus B is a total of 4 steps forward, 4 steps forward, and 2 steps downward. So 2 steps downward. That's your result. Is that okay, Shreya?
Yes, sir.
Yeah. Last one for today, but we won't be solving this problem in the class. This will solve in the next class. But I want you to write it down. Just write down the question. Don't copy that diagram. Removed. Just write down the question. The hiker begins the trip by first walking 25 kilometers southeast from her car. She stops and rests, sets up her tent, all that story. On the second day, she walks 40 kilometers. She walks 40 kilometers in a direction 60 degrees north of east, at which point she discovers a forest ranger's tower. Determine the components of the hiker's displacement for each day. Components of hiker's displacement for each day. What does components mean here? What is the total steps walked along the east direction and total steps walked along the north direction? That's what we mean by components. Determine the components of the hiker's resultant displacement R for the trip. That's your question. So you need to draw the diagram here. Tripti, can you help us draw the diagram? We'll start somewhere. Let's start over here. That's the starting point. That's O. A hiker begins the trip by first walking 25 kilometers southeast from a car. What does that mean? Southeast. Southeast from a car. So this is north. Yeah, this is south. Southeast means 45 degrees. Southeast always means 45 degrees, exactly between south and east. So the diagram would look like this. Southeast. So 25 kilometers southeast. So this angle would be 45 degrees. Agreed? It's exactly between east and south. So she sets up a tent for the night here. Let's call this point as P. On the second day, she walks 40 kilometers in a direction 60 degrees north of east. Can you help me out with that? 60 degrees north of east, what does that mean? "60 degrees north of east." You would have gone along the east direction, but you're going. Anirudh, what does it mean? 60 degrees north of east. 60 degrees north of east. Look at the wording. 60 degrees north of east.
So that way, like this, I guess.
North. 60 degrees north of east.
Sir, if we draw like a line parallel to the above, like passing through P parallel to the above line, and then 60 degrees from there, you would get.
Yes, yes. So draw the east direction. This is the east direction, isn't it? That is east. From the point P, that would be the east direction. Whatever dotted line that I've drawn there, that is east direction.
So east would be towards the left in her.
Yeah, no. Towards the right from the point P. Okay, how are you looking? That is also important. Okay, so let me tell it to you. This is the east direction. Do you agree? I've pointed it over here. Now all of us can agree. That right, left depends on which way you're looking at it, isn't it? So I think this we all agree with. That is the east direction. Yeah, because here's my compass. Look at that. Now I've pointed already what is north and east and all these things. Now we have to go 60 degrees north of east. 60 degrees north of east. So here's the east direction. We go 60 degrees north from the east direction. So we go somewhat like this. But how many kilometers do you have to go? You have to go 40 kilometers. You have to go 40 kilometers north, 40 kilometers at an angle 60 degrees north of west. So that's our second displacement. Let's call this point as Q. Let's call that point as Q. And here's the forest ranges tower. Okay, done. So the total displacement would be this OQ. That is the total displacement. Okay, now read the question again and try to solve it. Determine the components of hiker's displacement for each day. On the first day, what happened? What are the components? How many kilometers did he walk eastwards and how many kilometers did she walk southwards? Those are the components, isn't it? And the second day, what happened? How many kilometers did she walk eastwards and how many kilometers she walked northwards in the second day? Then you try to figure it out. Yes, I'll end my class here. I'll see you guys next year. Okay.
Yes, sir.
Yes, sir.
Any questions?
Meet you in next year.
Sorry?
Meet you in next year, sir.
Any
Sir,
questions?
Happy New Year in advance.
Yes, Happy New Year to you too.
Happy New Year, sir.
Happy New Year.
Happy New Year, sir.
In advance.
Thank you. Yes, your numbers. I hope nobody has left. Any questions? No? All right. Yes, Yashwardhan. Where are you? What is the speed of the Earth?
30 kilometers per second? Like in the rotation thing, if I'm right, I'm not sure.
Yeah. What is my speed, Sarvesh?
Sir is in rest.
Huh?
Sir, you are in rest right now.
No, I'm not at rest. No. I'm on the Earth. Earth is going around.
Your
So
speed is 30 kilometers per hour.
30 kilometers per second. But
Yeah,
the Earth is
30
going
per
around,
second.
going around the
Sir.
sun.
Sir, isn't the sun going around the Milky Way?
Yeah, that's what I told him. Earth is going around around the sun. Sun is going around the Milky Way. Milky Way is also moving.
The sun goes around the Milky Way. I thought it used to move forward.
No, it is moving around the center of the galaxy. You know how many rounds
Sir,
it has
Milky Way is
completed?
about
Do you know how many
like
rounds it has completed?
250.
Sorry, Rohit?
I don't know, sir. Sir, Milky Way is about 250 kilometers per second. It rotates.
So that much slower?
That is slow.
Per second.
That is still slow. 250
That is
kilometers.
very slow according to its mass and like according to its width.
How big it is, yeah. Yeah, I do not know the values, but I know this interesting thing that Sun has completed so far 20 rounds around the Milky Way. So it has gone 20 rounds since its inception, since its birth. So you can say in some sense, Sun is 20-year-old. 21 year means however long it takes to go around the Milky Way. You know how many years is that basically? How many Earth years is that? What is an Earth year? Earth year is going around the Sun, isn't it? So when the Sun went around the galaxy, how many times did the Earth go around the Sun? Do you know?
50 million.
250 million times. 250 million times. So Earth was going around the Sun while Sun was completing its round around the Milky Way. So Earth went 250 million times around the Sun.
So in 20 circles of the sun or one?
In one circle of the Sun, Earth went 250. So Sun, so far it has gone 20 rounds, isn't it?
So stop making us feel insecure that we are very slow in like speed.
Okay. So I'm answering this question like this. I know that Sarvesh asked, Yashwardhan asked me what is the speed of the Earth, but I cannot answer that question. Speed of the Earth with respect to what? Because one speed I can say it is going around itself at 30 kilometer per second. One thing is that, but it's also going around the Sun, right? So should I not factor into that, right? And the Sun itself is going around the Milky Way, so Earth is going along with that. So there is that additional speed now.
So, what is the speed of the Earth in respect to a person who is like from the space shuttle seeing the
space
Earth?
shuttle. Okay, if you're looking at it from the space shuttle, then the speed of the Earth is 30 kilometer per second. Okay, why? Because the space shuttle is also moving with the Earth, isn't it? Which is going around the Sun. So for the space shuttle, it appears that Earth is rotating. That's all.
So one fun fact: if space shuttle is also going in the speed of 30 kilometer per second, then Earth will be in rest for it.
Yeah, you are in such a space shuttle. Do you remember? Can you see that? You are in that space shuttle actually. Your house is that space shuttle, which is going around the Earth with the Earth, isn't it? So Earth appears to be at rest. So speed of the Earth is 0 with respect to the space shuttle that Sarvesh is in. With respect to a space shuttle that is outside the Earth, it is 30 kilometer per second. So yes, whole lifetime of a human on Earth is a baby step for the Sun around the Milky Way. It is not even counted actually. 100 years. Even if you live for 100 years, that's how insignificant we are. Actually, that's a relief. You don't have to worry much now, right? No matter what you do, what is the contribution basically? Nothing.
Sir, how do we know the width of the universe? Like, how are we so sure that it'll be like Sun will take so much time to go around?
The calculations, Sarvesh. See, all of these calculations can be made once you learn the theory of gravity as given by Newton. Okay, so based on the calculations of Newton, you can figure out what this one is. These are not measured. It's not like somebody sat with a clock and saw. Okay, no, you calculate these values. It's just like calculating what is the mass of the Earth. It's a calculation. It's not measurement. Why can't we use a telescope like Hubble as microscope to see what is inside subatomic particles? How can you? So, there is something that relates the size of the particles to the size of the lens, the aperture of the lens. Okay, so when you're looking at small objects, you want the aperture to be smaller. You do not want the light to spread, no? Right? When you're looking at distant objects, you want to gather as much light as possible. So whatever object that you use to look at distant stars, you cannot use that the same one to look at support. And how will you? It's a big thing out there. How will you turn that to look at this one? So when the light is coming from smaller objects over here, all the light is coming from this one. You can't zoom there. You cannot resolve things. Something called as resolution. Just look at resolution, meaning how can you distinguish two things as two different things. because you look at one tiny thing, one tiny dot. If your resolution is better, you can see them as many dots, isn't it? That is called as better resolutions, meaning you can distinguish two particles as two different things. That's what we need. We need better and better resolution to look at atoms. Not you cannot. I don't know. Not if you can look at atoms, but molecules definitely. So you go on resolving things. You go on zooming. That is resolving until you can see two things.
So which subject you did not study, sir? Like you right now answered a chemistry question. Before that, you said something in Sanskrit, which I have no idea. I actually forgot
No.
about
The
that.
thing is,
And now physics.
yeah, you are thinking that I know a lot. It's just that whatever I know, I tell you. But you think, okay, it's two all different things. They're not. I don't know much. Okay, if you go on questioning me, there will come a point where I'll have to say I don't know. Right? Nobody knows many things. Okay, we know a finite number of things. I don't know, for example, how this shirt is made, how to dye it, or how to color it. There are so many things in your room you do not know how they are working. So we are all ignorant in one sense. So no matter how smart you think you are, put yourself in a room, look around in the room. There will be so many things that you do not know about that room itself. Right now, the camera, I don't even know how it works. I know the principles behind the working of it, but how exactly the software and all of that, I have no idea. So always remember that. Whenever in a room, there are things that you do not know at all. And this ignorance cannot be removed, no matter how many PhDs you do. There will be still things in the room that you do not know. That's a good thing. If you figure everything out, then what's there to do? Any other questions? How much information can a supercomputer process compared to a human brain? Processing of the supercomputer is very fast. Very fast. Okay? Humans cannot do that. Humans cannot process information that we cannot process information that fast. This computer right now, I put 40,000 into 78,235. It will return me the answer immediately. That is processing, right? You are crunching numbers, the basic. But you cannot say this computer is smart. It's a machine. Right? Supercomputer basically is faster than this computer. It can do a lot more processing than this one. So whatever human brain might take years to do, computer will do it in seconds. Supercomputer will do it in milliseconds. I don't know. So it is very fast. How much information can a supercomputer process compared to human brain? A lot. I don't know how to answer that. Which supercomputer are you talking about? This much. Will that satisfy you? India's best, I do not know, Ishpat. See, I do not know. I don't even know what is India's best supercomputer. But I'm sure it is some IBM or some company like that. I think IBM has a supercomputer, right?